natural greenhouse effect is a process that happens all over the world. It is extremely important in life survival and for humans itself. It is important for everything on Earth as we know it today. Without the natural greenhouse effect, everything would freeze. What is the natural greenhouse effect anyways? Well, it is the absorption of thermal energy in the atmosphere by gases such as carbon dioxide, CO2, methane, CH4, water vapor, H2O, nitrous oxide, and 2O. So how does it affect the Earth? Well, many farmers use this effect to grow crops that are out of season, for example, strawberries or corn. Without this effect, the Earth would be 20 degrees Celsius cooler. So how does it work exactly? Well, waves emitted by the sun, or infrared rays, enter the Earth's atmosphere. They are then converted by our atmosphere into thermal energy, which are then either reflected or absorbed. Reflection. About 30% of the radiation is reflected back to space. Everything reflects radiation, such as a common table or counter. Albedo is the percentage of incoming radiation reflected by an object. So, for example, something shiny has a higher albedo than something that is dull. Darker colors, like black, reflect only 10%, while lighter colors, like white, reflect 90%. Absorption. 70% of incoming solar radiation is absorbed by the surface of the Earth and the atmosphere. So this includes most of our soil and grassland. The solar constant is the amount of radiation that hits the atmosphere, meters squared per second. This is a diagram on the greenhouse effect. So, indicated by the red arrows coming out from the sun, thermal energy enters our atmosphere, and most radiation is absorbed by the Earth. However, some of it reflects back out of our atmosphere back into space. Some of it reflects off of our atmosphere back into Earth. So this concludes the natural greenhouse effect. To sum up, it is simply the sun's emitted energy converted into thermal energy, which is then either reflected or absorbed back into the atmosphere. If it's absorbed, it warms up the Earth. If it's reflected, it goes back to space.
As you just learned in the previous chapter, the natural greenhouse effect keeps our planet warm by absorbing thermal energy in the atmosphere. The absorption is due to the greenhouse gases. The greenhouse gases consist of carbon dioxide, water vapor, nitrous oxide, and methane. However, humans have a way of emitting these greenhouse gases that form the anthropogenic greenhouse effect. What is the anthropogenic greenhouse effect? The main greenhouse gases emitted by human activities are carbon dioxide, methane, and nitrous oxide. The buildup of these heat-trapping gases entering the atmosphere creates the anthropogenic greenhouse effect. The two main human activities that create these gases are agriculture, which is farming methods, and combustion of fossil fuels. Now let's start with agriculture practices. Carbon dioxide is emitted from tractors and equipment. When the tractors use the fuel, it releases carbon dioxide into the atmosphere. Methane is released from the digestive system of livestock. When cows belch or burp, methane is released. Nitrous oxide comes from the fertilizer, crops, and manure. Deforestation, soil tillage, and land degradation release carbon from the land and reduce its capacity to absorb and store carbon. So as you can see, when we till the soil or we destroy the forest, we are releasing carbon into the atmosphere. Now, let's do combustion of fossil fuels. Since the Industrial Revolution began in 1750, combustion of fossil fuels has increased. When combusted, fossil fuels release nitrous oxide and carbon dioxide into the atmosphere, which are two of the three anthropogenic greenhouse gases. Below is a diagram illustrating the combustion of fossil fuels. As you can see, there are many types of combustion of fossil fuels. Trends in the main greenhouse gas concentrations in the atmosphere in the last 1,000 years. Carbon dioxide, methane, and nitrous oxide concentrations have all grown steeply in the last 1,000 years. Increases in concentration are measured in watts per meter square. Higher watts per meter square results in less heat energy escaping. This leads to an increase of temperature. As you can see in all the diagrams, they are increasing. The increasing concentration of greenhouse gases leads to more global warming potential. Global warming potential is a measure of the ability of a gas to trap thermal energy in the atmosphere over a specified time. However, water vapor is not included in the global warming potential classification because its concentration varies from place to place. The increase of concentration of greenhouse gases also leads to more persistence, also known as atmospheric lifetime. Persistence is the length of time that the gas remains in the atmosphere. Gases that persist longer can absorb more thermal energy over a long period of time. Persistence of carbon dioxide is not defined because it depends on the amount emitted and the various carbon sinks. Here is a chart illustrating the global warming potential and the atmospheric lifetime of the three main anthropogenic greenhouse gases. As you can see, the atmospheric lifetime of carbon dioxide results will vary. Methane has a global warming potential of 21 and an atmospheric lifetime of 9 to 12 years. Nitrous oxide has a global warming potential of 310 and its atmospheric lifetime is 120 years. So, to sum up the anthropogenic greenhouse effect, the anthropogenic greenhouse effect is due to the greenhouse gases being emitted by human activities. Remember, these human activities consist of farming and combustion of fossil fuels. So, in conclusion, with both these greenhouse gas effects occurring in the atmosphere, Earth's temperature will surely rise. If we do not stop this, global warming will surely occur, and we do not want that to happen. Thank you for watching our podcast.